It wants us to, this example, evaluate sine of theta, cosine of theta, tangent of theta, and again without a calculator, for theta equals negative 5 pi over 6. Again, two types of problems. We either know where theta is or we don't know where theta is. This time, we know where theta is, so first thing I would do is start sketching that. So sketch theta, and again, it's always assumed to be in standard position. What quadrant is this going to land in? Well, first of all, theta is in radians. If you're not familiar with radians, as far as where it's going to land in the quadrant 1, quadrant 2, or quadrant 3 or 4, then first thing I would do is convert to degrees. It's a lot easier to work with degrees. Negative 5 pi over 6 times, how do I convert this to degrees? Okay. Right now it's in radians, the units. I know it's either pi over 180 or 180 over pi, because we know pi radians is 180 degrees. And again, the unit analysis, I want to cancel out the radians. Radians has to go on the bottom, and pi is associated with the radians. So I know I have to put 180 over here. And now you can cancel out the units. And in this particular example, the pi also cancels out. Now this one, again, it's supposed to be done without a calculator, so you might want to get used to doing these calculations without a calculator. So while negative 5 times 180 will give you a large number, I would instead do 180 divided by 6 first. What's 180 divided by 6? 30 times negative 5 is what? So negative 150 degrees is this answer right here. And it's a lot easier to sketch negative 150 than it was the negative 5 pi over 6. So again, starting from the positive x-axis, which direction am I going to go? Clockwise or counterclockwise? Remember that if it's negative, you go clockwise. So negative, it's going to go, it's going to go negative 90. Now I know I have to stop somewhere here because this is going to be negative 180, so I'm just going to go ahead and more or less estimate that here. So this is theta equals to negative 5 pi over 6, which equals negative 150 degrees. Now remember here, this is where students make mistakes in creating this in creating the right triangle, which it is going to be a special right triangle. You want to make sure that you always go from the terminal side to the horizontal axis, because we want to find the reference angle. The mistake that students do is they go from this point and they go this way. That does create a right triangle, but remember that that's not the way I find the reference angle. Oops. So in this particular case, the reference angle is going to be this one over here, theta prime right there. How many degrees is this? 30. Now for reference angles, because they are acute, I know that we went in the negative direction. When you find reference angles, just use the positive ones, because negative is really just oriented to for direction, or used more for direction than it is for the actual value. Now, here's where the special right triangles come into play. If I look at this special right triangle, what goes opposite the 30 degrees? Well, in terms of sides, 1, square root of 3, or 2? 1, because that is the smallest angle. So I'm going to have 1 here. What is adjacent to the 30 degrees? Square root of 3, and the hypotenuse or the radius is going to be 2. That's why I told you guys to memorize those special right triangles, because you do have to label this appropriately. Now, what we want to do is now we go back and try to figure out sine of theta is equal to, well, we know sine from SOHCAHTOA is what? Opposite over hypotenuse. Now you use this picture with the reference angle and that right triangle. So this one is the opposite. This one is the adjacent. And I'm forgetting one thing though. And this is the hypotenuse. The orientation of these. If I look at this right here, the adjacent is going in which direction? The positive direction or the negative direction? Negative. So I do have to put that is in the negative region. The opposite is going downward. It's like as if you're plotting a point. If I plot this point, this one has to be negative. Okay. So make sure that you also put the sign associated, and the sign again comes from your sketch. Now sine is, yes, opposite over hypotenuse. The opposite is going to be what? Negative 1 over 2. So while we are finding theta, and theta is this negative 5 pi over 6, I guess I could have put sine of negative 5 pi over 6 is equal to negative 1 half. Cosine of negative 5 pi over 6 is, I use the reference angle sketch. Cosine is adjacent. Adjacent over hypotenuse. Adjacent here is what? Negative square root of 3, and the hypotenuse is 2. And then tangent is what? Opposite over adjacent. And opposite in this picture is, so now here, what's negative divided by a negative? Positive. So it's just 1 over the square root of 3. And if I simplify this times the square root of 3 over the square root of 3, I end up with the square root of 3 over 3. So just be careful with the signs when you do this problem. Well, it's supposed to be done without a calculator. What I'm not going to take away the calculator. What I would do is, well, I might take away the calculator, is I would check it to make sure that these values correspond to that.